Hi everyone, in previous video I have presented the form of circulation of the Green Theorem, and I want to just review with you that the Green Theory says and measure actually circulation means measuring tendency of a fluid to move in the direction of C, and C was the root of the region which influenced by the vector field F, and it was the integral of f dot dr. We could write that this is equal to integral of p dx plus q dy, which we can present over the double integral over the region D qx minus py dA. And here dr actually it is t dot ds because the tangent for every point defined by dr over ds. So another form we can write instead dr will be equal to t ds. And so we have another expression for this, which we can write f dot t ds multiply f ds is equal to double integral over region D qx minus py dx dy or dA. Now I want to present another form, which was the flux form of the Green Theorem. In order to understand actually this integral coming from which concepts, we have to come to this figure as you see in this picture. Here, if we consider the meaning of the flux actually is measuring how much the field passes to a given surface. If I consider the selected space, for example here I consider the space ES. So from this space the fluid is coming out, and I want to calculate the measure of this fluid coming out from the space. So, and if we come to this figure, you will see that here I consider ds here, and from this selected space n is normal over this space, and f is a vector field, so in the direction of n we have to compute the flux or compute the fluids is coming out from this space. So it means we have to measure the volume of this fluids compasses across this selected space ds. So volume is equal to base area multiply in height, and the base area, so I consider the ds or delta s or ds if I want to use after the integral instead the sigma, and the area is ds, and the height actually is the fluids coming out is the image of f over n in the direction of n as a normal to this space. So if I consider theta as the angle between f and n, so the image of f over n is f cosine theta. If we go to consider this image, so here will be f cosine theta. So here the height will be in the direction of f. N is f cosine theta in n as a normal, and here actually n choose with the small n. So here is meaning that f dot n, the dot product of f and n in ds, so dot product of f and n in ds or delta s. So we have to compute this v because it is the selected space, but over this we have many vector fields. For example, if in this space coming many f, and if we want to select ds for this space all coming, so we have to consider the sigma which change to this integral, and over to this. So the flux actually meaning of f product with n in ds, which make easy by calculating over the region d of px plus qy, which is the divergence actually, because px plus qy is the divergence. Here we have an example. If S be triangle with vertex of 0 and 0, 1 and 0 and 0 and 3, oriented clockwise, compute the flux of this vector field across S. So in this question, let's first we sketch this triangle. So here we have, this is x and y axis. If I consider 0 and 0 here, and 1 and 0 is here, and 0 and 3, suppose that here, sorry, we have this triangle here. And this is oriented clockwise according to the example. So it means that clockwise, it means first we come here and then here, and this is the direction. We have a tree, it is C1, suppose this is C2 and this is C3. To compute the flux according to the Green Theorem, we have the integral over on C or on the B, this is the region. I can put from D or C as of F dot in ds will be equal to double integral over region D. The region is this inside this triangle, and we compute Px plus Qy dA. dA is dx and dy. So as it is clockwise, but the Green Theorem is defined by counterclockwise, and C1, C2 and C3 is clockwise. We can then put the negative for this integral, because we have to consider this. So over the region D here, I can compute Px. First, can get the integral of P respect to E, which is around P over E equal to, and this is P, and this one is Q. So respect to X is 2x plus exponential of X, and Q over Y, 1Q over Y, which is equal to 0 plus 1 is 1. Now we want to evaluate this integral. So if you come here, the boundary of this region is oriented clockwise, while the flux form of the Green Theorem and also same circulation form, both oriented for the counterclockwise. So if we want to get this integral, here the round C, the round D or this is negative over C or round D, f dot n ds will be equal to negative over round over C f dot. So according to double integral, I can change to this double integral. Px is equal to 2x plus exponential of x plus qy, which is 1. And this one px plus qy, actually it is the divergence also, because divergence defined by this one. So we can get now over dx and dy. Now I have to evaluate this region. If we come to the figure, we will see that if I want to first use the y and x will change from 0 and 1, and y, if I consider this line which is parallel to y-axis, first intersects with this line, yellow color, and then with this line which is y equal to 0. So I have to write the equation of this line, which will be y minus here 0 equal to slope of this one 3 minus 0 over 0 minus 1 times x minus 1, because here is 1 and 0. So the line will be y equal to minus 3x plus 3. So here y will change from 0 till minus 3x plus 3. Now we can compute this double integral. First, respect to y, we get the integral 2xy plus exy plus y, and y will change from 0 till minus 3x plus 3. Then we get integrate over dx. We can replace instead y minus 3x plus 3. This will be 2x times minus 3x plus 3 will be minus 6x2, and 2x times 3 will be positive 3 into is 6x, and exponential of x times minus 3x will be minus 3x, exponential of x plus 3x, then y which minus 3x plus 2. If we put 0, so we will subtract instead y 0 0, instead y 0 it's 0, here 0, so we will get only 0. After simplification this term, we can get the integral 6x to this one, just minus 3x, and 6x will be 3x. Let I delete this one and write only 3. Now we get integral over dx, and we multiply with minus. The integral of minus in minus is positive. 6 over 3 is 2x, 3, and this one 3x in minus 3 over 2x2, and this one which needs to get integration by part. So if I suppose that for this integral x equal to u and exponential of x dx equal to dv, so derivative of x equal to du, and if I get integral, exponential of x is equal to v. So this one is uv minus this integral. Multiply together minus this. So here if I get the integral, we have here uv. So here uv is time in minus 3 also. So minus 3 uv minus 3 exponential of e minus will be positive 3 uv minus integral of v du, integral of ex dx, which is ex, and then integral of 3ex, which is 3 exponential of x, and for 3x also here should be negative, so here we have negative 3ex will be negative 3ex, and 3 can write in minus 3x, and x will change from 0 to 1. If I put 1, I will get here 2 minus 3 over 2 minus 3 is a positive 3 exponential power 1 minus 3 times exponential power 1 minus 3 exponential power 1 minus 3 minus, then we put 0, 0, 0 and 0 will be here positive 3 and positive again 3. So we will have here, this will be deleted and this will be deleted. 3 plus 2 is 5 minus 3 over 2 minus 3e. Then we have 10 minus 3 is 7 over 2 minus 3e. So we get the answer here 7 over 2 minus 3e. Let's use Maple and calculate by this software. To use the Maple, programize and see how we can check the answer of that flux in that example. First, I define the vector field component, which p is equal to exponential of x plus x power 2 and q equal to x plus y. So the vector field f will be p and q, small p and q. And now I can define, here I missed the semicolon, and now I want to get the divergence, which if I put as A1 is equal to differentiation of P respect to X plus differential of Q over Y, which it is exactly the divergence, and even I could write by, and so A1 is equal to this one. Even I could use by linear program. If I use with linear, then I can write, for example, A1 equal to diverge of F respect to and Y. So if I run, I will get the same answer. Now I want to plot the vector field, so with plots I use the program for field plot. So field plot of f, the region of x is, for example, from -3 till 3, and y also from -3 till 3. I will put this in V1 and after display because I want to show in same diagram. Now I can use the region I plot when I put in V2 equal to plot the region, the vertex I put in accolade crochet of 0 and 0 first vertex, and then 1 and 0 and 0 and 3. Now I can run. Something is x equal -3 till 3. Okay. Field plot. The field plot didn't write. Okay, now I display field plot. Sorry, I missed E here. Now we can run and we will see that this is the vector field, and here is the region of this triangle. So now we can even find the integral. So the flux equal to integral of integral is the double integral of the diverge was I use as A1, so A1 the name of it, and y from 0 to minus 3x plus 3, and x change from 0 to 1. Now if we run, we will get the flux is equal to minus 7 over 3 plus 3e, which is the same answer when we calculate by hand. Thank you for your attention. I'll be blessed. Hope this video also be useful for you. Please subscribe to my channel. If you have any question, I will be happy to answer and reply by email address which is available in my channel. Thank you very much.